Good morning to one and all present here. It gives me an immense pleasure welcoming you all on 15th day session of SPSS program. It's a short-term course organized by SSMRV College in association with Indian Teachers Education Community. So we are in the 15th day, the last day session of this program. I hope all the participants have enthusiastically participated and got some good knowledge over this session. And it gives me an immense pleasure in welcoming our respected principal to address this session today. Sir, I welcome you, sir.
Please, can you put this slide? Yes. Yeah. Good morning to all. I'm Dr. Anil Kumar, principal of SSMRV College, which is managed by one of the most reputed institution in India, that is RV Educational Institutions. And this runs around 20 institutions from LKG to PG professional courses like engineering, architecture, dental, and degree colleges, schools. So there are about 20 colleges, institutions are run by RV institutions, and it is one of the oldest, started in 1940 by a freedom fighter. And SSMRV College is about 34 years old institution, which runs undergraduate programs like BCom, BBA, BCA, and MCom courses. And of course, we have specialized programs like enterprise technology and data center architecture in BCA. And of course, AI and machine learning programs also as an additional programs in our college. So our college is accredited by NAC with A grade. And also, from past 3 years, our college has been ranked among top 5 colleges in India as per India Today ranking for the value for money, actually, because what we collect, the fees, is very less compared to the kind of offering we give, that the kind of the facilities we provide in our institution. So I'm very happy to share this information. Of course, our placement is about 96%, and our students are getting ranks in the universities. And of course, all this is because of one unique model which I have developed, which is called as 360-degree education for wholeness model. This is a very unique model which I have developed with 5 dimensions. I think for more details, you can go through my website, sanilkumar.com or ssmrv.edu.in to know more about the unique model which we have developed, which helps the students and the faculty, of course, for the holistic development in the real sense. That means they are really engaged and provided all kinds of opportunities and to the students for their holistic development. So that's the reason our college is also known as the knowledge platform, a knowledge destination, and we also encourage a lot of such programs even for faculty members. And we have been, I think, more than 40 programs. We have 40 to more than 40, I think, programs have been organized during this lockdown period like this. And of course, most of the programs have been well received by the participants. Some of the programs were 200, 300, up to 500 we have seen. So the kind of popularity we have gained over a period of time is great, actually. All this because of the kind of association we have with the people like you. So this is one of the most, it's slightly different because this is for 15 days. I think this is the only one program. All other programs are 2 days, 3 days, 5 days, and all we have done. And this is very unique because it is 15 days program. So it is a unique program. And of course, it is unique because of that. It is because it is done by a very well known and very reputed and of course very knowledgeable resource person, Dr. D.N. Sansanwal. I think I have seen even earlier webinars also. So I have seen the presentation, the way he explains in a simple manner, and which is very essential today for all researchers, even for students who are doing BBA or students doing PG courses, MPhil, PhD, or even for the presentation of their papers, publications. These kind of initiatives are really helpful for all the participants. I'll tell you, I think it is wonderful effort from Dr. DN Sansanwal, and I'm very happy to be part of your group, and also appreciate the effort which is taken by Dr. Pramod Kumar Gupta, who is responsible in getting associated with our institution, with our Department of Computer Science HOD, and Dr. Shanti Krishna, and also Professor Neeta and her team. So I'm very happy that we have associated with Indian teachers education community in this way, and there is long way to go. I think we are happy to share, happy to be with you for any such programs even in the future. So I really thank and appreciate the kind of service you are rendering for the cause of education in the recent now, and it goes a long way. And I assure you, and also I'm willing to be part of your programs even in the future. So I take this opportunity and also appreciate the participants. There are more than 250 participants who are showing interest. I should appreciate their patience, because it is 15 days program. It's not that easy, of course. So I appreciate all of you for being very patient and showing such kind of interest in these kind of programs. So it will really help you, because as a researcher, I know how important it is. Okay, so I once again thank the organizers, Dr. Pradeep Kumar Gupta, and resource person Dr. DN Sansanwalji, and the entire team, and the Department of Department of Computer Science, SSMRV College, for organizing this particular program. So I wish I think this is the last webinar, that is 15th day. 15th day. I'm really thankful to all of you for having this particular program. Thank you so much for being with us. Thank you.
I had come to your RV Teachers Training College for NAC program. Hello.
Hello, sir. Hello.
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 I came to your RV Teachers Training College.
Oh, okay. That's nice, sir.
Yes, for the NAC one. I was the chairperson.
Oh, okay, sir. Okay, sir. So thank you, sir, being associated with RV institution.
Thank
Next
you.
time when you come to Bangalore, please visit SSMRV College, sir. We will meet up on some time.
Yes, definitely. Thank you very much.
Yes, sir. Thank you so much, sir. Thank you so much.
Thank you. Okay, can I start now?
It's my great honor to welcome you both, the eminence in the education field. It's my honor to greet you both today. And it's a matter of great pleasure and honor for me to welcome our resource person. And before that, I would like to thank our principal for addressing this session today. And we hope that with your energy, enthusiasm, and focus on education and learning, our institute achieves greater excellence, sir. Under your leadership and guidance, may we reach the next level of glory. I once again, On behalf of SSMRV College and Indian Teachers Education Community, I thank our respected principal, sir, Dr. S. Anil Kumar. Thank you so much, sir. Now, I would like to welcome our resource person, Dr. D.N. Sansanwal, sir, to this program. Welcome you, sir.
Dear friends, now you know me because today, the 15th day, it's a long association with all of you. I'm DN Sansanwal, and this is my email address, so you know it. Dear friends, so far we have been talking about various statistical techniques and how to analyze the data using SPSS for those statistical techniques. During my presentation, I was emphasizing that whenever you want to use t-test, one-way ANOVA, two-way ANOVA, three-way ANOVA, one-way ANCOVA, two-way ANCOVA, three-way ANCOVA, correlation, partial correlation, multiple correlation, and regression analysis. Your data must be very, very strong data. That means your data must have either the scale of measurement as interval or the ratio. By chance, if you do not have data either on interval or ratio, then what do? Does it mean that there is no technique available when the data are either on the nominal scale or on the ordinal scale? You know, if you remember, they, I think on the first day, I did tell you the 4 scales of measurement. My dear friend, there cannot be any variable which cannot be on any of these 4 scales. It has to be on one of the 4 scales. When someone is working in Hindi or in English or in Malayalam or in Kannada or whatever it is, there also there will be a scale of measurement. In science, there are scales of measurement. In social sciences, etc., etc., etc. And on that day, I said that there one scale of measurement is a nominal, that is the lowest one. Another is ordinal, higher than the nominal, and higher than ordinal is interval, and highest is the ratio. But the interval and ratio are the most important. When your data are on these scales, then it's a very, very strong data. The more strong the data are, the more strong statistics you require to analyze them. It cannot happen that you have the weak data and you use a strong statistics. It is something like this. In the wrestling, you cannot have 2 people, okay, one is very weak and the other is very strong. Then there is no sense of wrestling. You have to have both which are strong enough. And that is why when they are taken on the basis of their weight, etc. So now today, because it's the last day, so I just want to give you a feel. Understand, in 15 days, the complete statistical techniques cannot be covered. it is impossible to cover. But I have tried my level best to give you some idea as how to write the objective pinpointedly, and then decide that whether you should write the hypothesis or not. And if you have written a hypothesis, then which statistical technique do you use to test that hypothesis? Okay. Now, today, since being the last day, so I am touching now two techniques which falls under the domain of non-parametric statistics. So far, whatever the statistical technique I have covered here, all of them were belonging to the parametric statistics. But today, I will take you to some statistical technique which belong to non-parametric statistics. Okay. And I think I did differentiate between parametric statistics and the non-parametric statistics. And I did tell you that parametric statistics is more powerful in comparison to the non-parametric statistics. Okay. So one technique which is very, very, very popular, I will not say useful, popular amongst lot of people, and that is the chi-square. Now, this chi-square technique, if you have to use, then this is not a very strong, very powerful statistical technique, because when I give you the details, you will realize that the all assumptions are not very strong assumptions. And since the assumptions are not very strong, therefore the test is not a very strong one. And when I'll come to the assumptions, I will explain you that why it is like that and why it is not like that. So chi-square test and how exactly it has to be used, and how SPSS. See, when I talk about the entry of the data, you have to be very, very, very careful, because when I tell you that when you use SPSS, it is sometimes easy to find the statistical technique, because when you go to compare means, it will give you those, and when you go to the other one, it also gives. When you go to correlate, it gives. When you go to regression, it gives the list. But sometimes to find the chi-square is a problem, so you have to be slightly careful, and I will tell you now, you pay attention. But it does not mean when I don't say you don't pay attention. Okay, you pay attention. Okay, all right. Let me tell you the today's sequence which I have to have. I will tell you who invented, in fact, chi-square. All these statistical techniques have been given by someone. Okay, so we must know the name of that particular person. Then another is when to use chi-square. Then uses of chi-square goodness of fit test. This word is very, very popular amongst some of the researchers. That goodness of fit. Okay, what does it mean, etc., and how the chi-square is goodness of fit test, so how to use and things of that variety. Then I will take you to the assumptions which your data must fulfill if you want to analyze it with the help of chi-square. And then I will tell you the uses of the chi-square, not uses of goodness of fit. but uses of chi-square. Then I will give you the objectives, how the wording of the objective should be there. And you have seen when you are writing the objective, whose data you want to analyze with the help of one-way ANOVA. And when you want to analyze the data with the help of one-way ANCOVA, you have seen the difference in the wording of the objective. And that is what makes it systematic. And that's what it makes it pinpointed. Because things have to be very straightforward. So here I will tell you how will you word the objective. That's a very important thing. And then the formulation of hypothesis. Then how will you analyze the data, and then how you will really use SPSS. Okay, all right, fine. So let's say the name of the inventor. See, this statistical technique can be used only and only when you have nominal scale data. If you have ordinal scale data, then you cannot use chi-square. But if you can convert ordinal scale data into nominal scale data, then you can use chi-square. And ordinal data, scale data, are stronger than the nominal scale data. Now, if you have data on the interval scale or ratio scale, I told you that the higher scale data can always be brought to the lower scale, but the vice versa is not possible. So the ratio scale data, you can convert it into the nominal scale. The interval scale data can also be converted into the nominal scale. So if you have a nominal scale data, then you can use the chi-square. And this chi-square properties were first investigated by Carl Pearson in 1900. So this was the year in which he gave the properties of the chi-square. And you know the chi-square distribution. Okay, so the name of the inventor is Carl Pearson, and it is in 1900 that he gave this. When to use chi-square? It can be used to study the association between the variables. I gave you the difference between correlation and association. And I hope you remember, because the examples which I gave, I took it from the daily life. Because it's always better to take examples from daily life to understand the concept. So therefore, you have to, if you want to study the association, then you have to use the chi-square. And when you are studying the association, your data must be on the nominal scale. Chi-square test is intended to test how likely it is that observed distribution is due to chance. Whatever the data you have in different categories, whether this data which is in different categories or classes, okay, is it by chance or is it not by chance? That's what it will tell you. Okay. Next, this chi-square is also called goodness of fit statistics, because it measures how well the observed distribution of data, observed distribution of data fits with the distribution that is expected. Now there is always a observed frequency and then there is a expected frequency. Some of you must have done chi-square numericals also, that you are given the observed frequencies and then you can have a expected frequencies. So therefore it will tell that how well the observed distribution, that means observed frequencies, they fit with the distribution of the expected. Whether the expected distribution and the observed distribution, is it same or different? This is important. Okay, if it is same, then how do you know it is same? If it is not significant, that means it is same. But when the chi-square value is significant, then it means your observed and expected distributions are different. Your observed distribution differs from your expected distribution. And if it differs, that means there must be some association. So therefore, goodness of fit is that's what, so it tries to find out this thing. Okay, and more you will understand when I take the numerical problem, the data, and then I will show you. Okay, a chi-square test is applied when there are two categorical variables from a single population. Population is the same. You can't take two different population. Population is the same. If it is class 10th students, it is class 10th students. And you have to have data only from that. If it is IT professionals, you have to take data from IT professionals. If these are commerce, you have to take data only from the commerce. And it is the two variables which are discontinuous variables. When I say two categorical variables, means discontinuous variables. Because discontinuous variable will always be in the some categories, some classes, some groups. But if it is a continuous variable, then of course it is not. But continuous variable can be divided into discontinuous. As you know, I gave the example other day that if it is height, you can say above average height and below average height. You have divided people. If it is weight, you can say average weight, say above average weight and below average weight. So that's how you can do the classification. That's not important. It is used to determine whether there is a significant association between the two variables. Just now I have said association. Okay, and when I say association, there must be the two. If there is only one variable, you can't have association. Okay, so that's what you have to do. And this chi-square is represented like this. It is not X. See how it is done. So the symbol for t-test, you know, it is small t. Correlation, you know, small r. Multiple correlation, you know, capital R. Okay. So an analysis of variance, you know, capital F. So like this. So chi-square, this is the symbol which is used. So you should know the symbols. It's a very important thing. So this about when to use chi-square. Now, I want to now tell you the uses of chi-square goodness of fit. Where am I going to use it? The purpose is used to decide whether there is any difference between the observed value and the expected value. I told you a few seconds before. So goodness of fit will tell whether your observed frequency and the expected frequency, do they differ or not. So it is just a repetition to make you just to aware. For example, one may like to test if it has been drawn from a normal population. Okay, that's fine. All right. The chi-square goodness of fit test is appropriate when the following conditions are met. Number one, the random sampling method is used. Okay, so that means if you have the data on the basis of non-probability, then you cannot use the chi-square. It is a random. Another is your variable must be discontinuous variable. It's not a continuous variable. If it is a continuous variable, you have to make it into the discontinuous. A continuous variable can be converted into discontinuous. You know it very well. Then your expected value of the number of the sample observation in each level must be at least 5. So when you have the frequencies, if there is a cell or there is a category or there is a group where the frequency is not 5, then it is difficult. You have to use then a correction which is called a Yates correction. So therefore your frequency has to be at least 5. Then another is, just a second. Okay. Another is assumptions. Now the assumptions are the data in each cell should be frequencies or counts. You know, counts are frequencies, frequencies are counts, rather than percentages. Some of the researchers, they want to use chi-square when they have the percentages. No, it cannot be done. Why? Because when you have the frequency and you convert it to the percentages, the frequency gets inflated. Say when you have the marks, if it is you have got 20 marks out of 100. Okay, now if you have 20 marks out of 50, what do you say? It is 40%. But in reality, it is what? It's not 40%. It is 20 marks. Okay. So when you convert the frequencies into the percentages, then it gets inflated. And therefore, that is not correct. So those people who have been using the chi-square, when there are percentages, then they have to be, yes, if you have a huge data, then it is very different. Huge data is fine, but if you have a small data, you should not have the percentages. Then another assumption is that the variables are mutually exclusive. This information I have given you earlier also. It is mutually exclusive. That means one particular person will fall under only one category. Okay, either this or this. It say, when I say that research methodology is useful and I say agree, undecided and disagree, then the person who is giving, he cannot say agree as well as undecided. No, it's not possible. If he says, either he has to say agree or he has to say undecided. But the person, if he says agree as well as disagree, no, it's not possible. So either he has to say agree or he has to say disagree. So therefore, the response must be only in one particular class and one particular category or one particular alternative. This is very, very, very important. Okay? Of course, if same subjects are tested over a period of time, I'm sure, no, I think I did not tell you, or I did tell you. Yes, I did tell you about the time series. It is the same subject who is tested a number of times. So therefore, if you have one group, you test at time 1, test at time 2, test at time 3, then you cannot use chi-square. It's not possible. Okay. So therefore, if the same subjects are tested over a period of time, then you cannot compare them. And so chi-square cannot be used. Because it is the same person will be in this, will also be in this, and will also be in this. So that the mutually exclusive condition is violated. So therefore, you cannot do it. Maybe some other technique will be applicable, but not this. Another is the study groups must be independent. When you are saying male and female, they are independent. Someone is male and someone is female. Okay. When you say one student is in the government school, another is in the private school, they are independent. One student may be in commerce, another student may be in science. They are independent. So you have to have the two groups and they must be independent. Then another is the value of the cell, expected value should be 5 or more. You know, I told you expected frequency and observed frequency. Okay, so your expected frequency should be 5 or more. There I said the observed frequency. Now here I am also saying expected frequency should also be 5 or more. You cannot have expected frequency 0, and expected frequency depends upon your observed frequency. So if observed frequency you have you do not have frequency less than 5, so therefore your the expected will not be. And then another is the 80% of the cell, and no cell should have the expected frequency less than 1. If there is some cell which has a expected frequency less than 1, then of course it cannot be. Now this assumption, just now I have said, is likely to be met if the sample size equals at least equal to the number of the cells. Say if you have 3 cells, okay, and then you must have 3 cells multiplied by 5 means 15. If you have 4 cells multiplied by 5, that makes 20. So if you have 20 subjects, then in each cell the number of the observation will be 5. So if you increase the cell, then the sample size has to increase, because so many subjects then you have to take. So that's what now the essentially this assumption specifies that the number of the cases need to be. So that's what the sample size, which sometimes people ask, what should be the sample size for the chi-square test? If you have to use chi-square test, then you say number of the cells multiplied by 5, that is the minimum you have to have. Okay, fine. Another is, if there are two variables and both are the discontinuous one, and they have to be on the nominal scale. If you have data which is on the ordinal scale or on the interval scale or ratio scale, you have to convert them into the nominal scale. This also I told you. And if you fail to convert, then you cannot use the chi-square. And while chi-square has no rule about limiting the number of the cells, say how many cells should be there, or how many categories should be there, or how many groups they should be there. Now, when you are having the categories, you have in the classes, it should not be too large. So normally they say it must be maybe maximum 20, but should not be more than 20. Because if it exceeds 20, then interpretation becomes very, very difficult. Calculation you can do, but interpretation becomes difficult. So that is another limitation. That means when I have a Likert type scale where I have the 5 options, so that's fine. I can have 7 options, fine. I can have 9 options, fine. I can have 11 options, but I cannot have 30 options, because then the cell size will increase so much. If you have 20 multiplied by 5, then your sample size must be 100. But if you have more, then you see, and therefore, so it's not. And that is why when chi-square when chi-square test is used, people do not take larger number of the categories, they have less number of the categories. Now, some of the uses I have already said under goodness of fit, but once again to reiterate that the chi-square is used whether the distribution of discontinuous variable differ from one another. Okay, you have a discontinuous variable, whether it's in one case and the other case, whether the distribution is the same or distribution is different. Chi-square is intended to test how likely it is that observed distribution is due to chance. This I have said, whether it is by chance or it's not by chance, you can find out that. And it is also called goodness of fit. This I have told you. Okay. All right. And chi-square test of independence is used to determine if there is a significant relationship between the two discontinuous variable, and relationship shared with the different values of the another variable. Okay, that just now I will take one example and will explain. Now I am taking the objective. Suppose my objective is to study the association between religion and home problems during COVID-19 of teachers. If I want to find out that, because I have written association. Second objective is to study the association between religion and home problems during COVID-19 of male and female teachers separately. Another objective can be to study the association between religion and home problems during COVID-19 of government and private school teachers. Say here the variables are two. One variable is the religion. Now, to which religion do you belong? So the information is only on the nominal scale. And the problems which you have, it's again on the nominal scale. So both the variables here which I am taking, they are having data on the nominal scale. And therefore, you can use chi-square, no problem at all. Okay, now, so these are the three, and for each, I can still write as many as you like, no problem at all. Just by example, for example purposes, I have taken these three. And if these three are the one, then what will be the hypothesis? It is like this. There is no significant association between religion and home problems during COVID-19 of teachers. For the second objective, there is no significant association between religion and home problems during COVID-19 of male and female teachers separately. And for the third one, the hypothesis is there is no significant association between religion and home problems during COVID-19 of government and private school teachers separately. Okay. Now, I have another one. Okay, this the another. Okay, it is slide. Okay, another objective is to study the relationship between gender and reaction towards new education policy of university teachers. Another to study the association between gender and reaction towards new education policy of science and commerce university teachers separately. To study the association between gender and reaction towards new education policy of central and state university teachers. This can be another objective, and hypothesis can be there is no significant relationship between gender and reaction towards new education policy of university teachers. For the fifth objective, the hypothesis is there is no significant association between gender and reaction towards new education policy of science and commerce university teachers. And for the sixth objective, the hypothesis is there is no significant association between gender and reaction towards new education policy of central and state university teachers. So this is how you can write, and that's fine, not difficult. So I once again tell you, if you write your objective pinpointedly, then hypothesis you can write very nicely. Now, I will take the data and I will tell you how exactly the data you have to enter if you want to analyze with the help of a chi-square, and then the whatever the results you get, how will you make the table and how will you interpret. And now we go to the SPSS. So now I take you to the SPSS, and this is my SPSS, and here I'm taking my, as usual, my Word file so that I can write objective. Okay, so let me make it little bit, increase the size so that you are able to see it. Okay, I find fine. Suppose, dear friends, let me take one example and then I think I will be all right. Say, suppose if I ask you a simple, not a question, but I want to have your reaction. If I say research, or let us say, the online teaching is useful. Suppose this is the one, and I am asking the people to tell me that do you agree? Okay, this is one choice. And another, if I ask people, okay, why don't I just insert the table and then I think that will be much better. All right, I'm inserting the table. Suppose here say statement, and here I say, for example, agree, and here I say undecided, and here I say disagree. Okay, and suppose this is my this is what I'm asking you. If I ask the large number of the people, then it is possible that some people may say, if I have, let us say, 20 people, okay, then some people may say 8 people may say agree, okay, say 7 people may say undecided, and the 5 people may say disagree. So that makes my, this is the, I can say total here. Okay, so the total here is 20. Now I want to find, this is what is called observed frequency. Now I want to find out whether these observed frequencies are these just random, or these are not the random, but these frequencies reflect the genuine reaction of the people. And if that is so, then you have to now analyze this particular data with the help of the chi-square. Okay, and for this, now if I have to write an objective, then how will I word the objective? And here it is online, है ना? So to study the difference okay, to study the reaction, of students towards online teaching, to study the reaction, I'm sorry, to study the reaction towards online teaching of students. Okay. All right. If that is what I have to do it, then now this is the data, and therefore okay, I think I say to study the difference in observed, to study the differences observed and expected frequency, to study the difference in observed and expected frequencies in respect. Yeah, that's okay. In respect of, now this is the one. And if this is the one, then how will I say write my hypothesis? Take my hypothesis can be I'll say there is no significant difference I say there is no significant difference in observed frequency. Now let me take this example first and then I proceed further. Now you know that here there are 8 people out of 20. Now if I convert it into percentages, now you say it will get inflated. If I convert it into percentages, so that means it is 40, 35 and 25. 40, 35 and 25. Just see the difference. Now here 7 and 5, difference is not much. But if you say 35 and 25, the difference get inflated. So it is better that if you have the less number, do not convert into percentages. If I have this my data, then how will I enter the data and how will I test this hypothesis? Okay, let me now go to this one. Now here I go. Now here I say I want reaction, because this objective is only the reaction. So if you want, I can write the complete reaction towards online teaching, or I can just say reaction. Okay, and if you have reaction, how many levels are there? There are 3. What are those? Agree, undecided, and disagree. Now I name them. One indicates agree, 2 indicates disagree, and 2 indicates undecided. And then 3 indicates disagree. Okay, so this is disagree. I go ahead. So I have entered. Now I go to my data file. Now here Now here in the data file, now you know that agree was the data which you had. You know, there are 8 people who said agree, and agree means 1. So when I say 1, this I have to enter 8 times. So I have entered the data. Now you see the undecided is 7. So now what I do, this undecided is represented by 2. So I say 1, 2, 3, 4, 5, 6, and 7. Okay. And now next is my disagree. And this disagree is 5. And disagree I represented by 3. So I say 1, 2, 3, 4, and 5. So this is how you have to enter the data. So if you have large number, say 400, now to enter the data of 400 is not, my dear friend, very easy. So you have to understand that. Okay, if this is what I have entered, now I go to analyze. Now can you tell me where should I go now? You know that chi-square belongs to the non-parametric statistics. So if you have this information, then you will not bother, you will directly go to the non-parametric statistics. And when you go to the non-parametric statistic, now see, immediately the chi-square is here. Okay, so I can go to the chi-square and I can click here. Now when I click here, now I have only one, so I shift it on this side. Okay, now let us see what is the option. Now do you want descriptives? No, I don't want. Fine. Then I say okay. And this is my result. You know that agree there were 8, undecided there were 7, and disagree there were 5. So total 20. And this is the chi-square you have got. So the chi-square is 0.700, and this is the degree of freedom to 3 alternatives. So 3 minus 1 is 2. And the significance is 0.705. That means 70.5% error. So that means this value is not significant. So let us go back to our and write. Since I have already put this particular data, so what I can do is I can just copy this, and I may like to use it for interpretation. I'm using it for interpretation. Okay, now I can add one more column here, and this I say the chi-square value. Chi-square value. And this chi-square value was 0.70. Okay. All right. Now, if you want to change the size, you can change the size. Okay. Let us see this was my objective. So I'm just copying it and pasting. I have copied and now I'm pasting it here. Just paste it. Okay, fine. Let us see. Now, what is the caption heading that you want me to write here from this particular? So this is difference in observed and expected. Observed and expected frequencies of reaction towards online teaching of students. Okay. Now, this is the heading I have written, and this is from this. Then I say the first objective was to study the difference in observed and expected frequencies in respect of reaction towards. Okay. And then I say the data were analyzed with the help of chi-square test, and the results are given in table 1. Okay. Now here I can table it is 1, and this is the table which I had made. Okay. So now I have to write. What should I write here? Okay. It is because there is only one statement, or if there were more than one statement, if I take another statement, then I should say statement wise. But here it is only one statement. So chi-square for the statement on online teaching. Chi-square, or you can say reaction, you can say statement wise reaction, because the reaction is towards this one, isn't it? So because here only one, so I can say reaction towards online teaching of students. Okay. Now here I say from table 1, it can be seen that the chi-square value for online teaching is 0.70, which is not significant. it indicates that there is no significant difference. There is no significant difference in observed and expected frequencies of reaction towards online teaching of students. Okay, because chi-square is not significant, so you say that there is no significant difference in observed and expected frequencies of reaction or in respect of, whatever you like, no problem at all. Now I say thus the null hypothesis now this was the null hypothesis. Okay, T, I can make it small, no problem. Okay, this was the null hypothesis. Thus the null hypothesis that there is no significant difference in observed and expected frequencies in respect of reaction towards online teaching of students. It may therefore be said that students, that the reaction towards online teaching of students was random. So that means the students did not okay, we can say that. It may therefore be said that reaction towards online program, on students, it may therefore be said that reaction towards was random in nature, was random. That's all. Response towards was random. Finish. So this becomes the reaction towards online teaching of students was random, or students gave responses randomly. The students' responses in respect of reaction towards online teaching of students was random. Okay, or this, okay, fine, no problem at all. Wording you can change. And if I want okay, so I can say this was mine. Let me take another example, dear friends. Suppose I want like this. Okay. I'm just trying to say whether I should go up or I should come down. Okay. Suppose I want something like this. Say, if I say like this, that to study the difference in observed and expected frequencies in respect of reaction towards COVID-19. COVID-19 of students. And here I have this hypothesis. And here the hypothesis is that there is no significant difference in observed and, okay, suppose I have the data like this. Okay, I'm making a table here, and let us say insert a table, auto fit. Suppose I say here statement. And here I say, for example, I say strongly agree. If I write essay, so essay means strongly agree. I will give you the abbreviation. Essay means strongly agree. Strongly agree. Okay. And if I say A means agree. So if I write here now agree, and UN means, and if I say U means undecided, or you can say neutral, no problem at all. Choice is yours. Say U. And if I say that disagree, disagree, so I say D. And if I have, let us say another one, if I say strongly disagree, and this I say S, strongly disagree. So let me make another column here, and let me make another column. Okay, and this is strongly disagree. Okay. Now you know what was my objective. Objective was reaction towards COVID-19. So here I say reaction towards COVID-19. Okay. Suppose I ask the people, the students, and let us say here there are 20 students, and suppose here there are 7 students. Suppose here there are 8 students. Suppose there are, say, 12 students. Okay. And let us say if there are, say, 9 students. So I have 20, then 7, then 8, then 12, and then 9. So I have 46. So the total here is 46. Okay. So I can write total, and then I can change if I don't need it. So it is 46. Because 7 and 8 is 15. 15 and 2 is 17, and 9 is 16. 26, 2, 1. Oh, is it okay. 7 और 8, 15, 16, 17. No. Okay, it is 56, not 46. It is 56. It is 56. So count, you can count it, no problem. Let us now go to the, so I am now defining another one. I say reaction 1. And for strongly agree, I want now 20 and this is 10. Now you see how difficult this will be when you have to enter the data. Now I have to define, let us say, let's say reaction 1, because I already have a reaction, and here I'm taking the 5 levels, and number 1 I'm saying strongly agree, and then I'm saying agree, okay, and then I'm saying undecided, and then I'm saying disagree, okay, and then I'm saying strongly disagree. Okay, this you have to define like this. If you don't define, then computer will not recognize, it will be difficult for you. Okay, now I go here. Now I have 21. So I go and 20. Till I come to 20, I can keep on entering the data. My 20. Then I have 7. That makes 27 will be 2. Okay, 27. Then I have 8. That makes 35. So then my undecided is 3. So I have to take 3 8 times. 35. And then I have the disagree, it is 12, and disagree was 4. So I should say, and 12 means 47. So I say 4. Okay, it is 47. Now it is 9 will be strongly disagree, and that was 5. So I have to say 9 times, and 9 means 56. Okay, so that means I have completed it is 56. Now understand, if you have 300 or 400 data, will it be easy for you to enter, or will it be very, very difficult for you to enter? I'm sure you'll say it will be very difficult. Okay, so that is why you have to decide. All right. Now I go to analyze, and I go to the non-parametric, and I go to chi-square. And now this I can take out, and reaction 1 I'm entering here, and then I say okay. Now just see, this is the chi-square value is 9.893. And 9.893, and degree of freedom is 4, and my significance is 0.042. So that means 4.2% error, and you can have 5% error. So that means here you get a significant value of chi-square, and the chi-square value is 9.89, and it is significant at 0.05 level. Okay, so therefore I can go to my this one, and here instead of chi-square I will write, instead of this I will write chi-square. If you want, you can use the symbol also, the choice is yours. Chi-square value. Chi-square value, this chi-square value is 9.89. And you know, this is significant. Now, if you want that, you can put a single star. If you want, you can put a single star and put a single star here, and then you say significant at 0.05 level. But if you do not want to do this, if you want to, then right here, then you can add one more. You can insert one more and say here, remark. And this you have p value. So p is less than 0.05. And make this p the small. Suppose I have this. Okay. And now let me remove this also, because I don't want this. This all you have understood. Now, let me go and take my objective. What was my objective? My objective was this. So I'm just, now you know the objective, you know. So you have to, if you want, you can copy, because you can from here to here. Okay, so I can copy from here to here, and now I can make. So difference in observed and expected frequency of reaction towards. Now I cannot write online teaching. I have to write COVID-19 of students. And here I should change. The second objective was to study the difference in observed and expected frequencies in respect of reaction towards COVID-19 of students. The data were analyzed with the help of chi-square, and the results are given in table 2, and therefore you have the table 2, and you have reaction towards COVID-19 of students. So this I can remove, and this is my table. Now I can say from table 2, it can be seen that a chi-square for reaction towards COVID-19 is 9.89, which is significant at 0.05 level, with BF equal to 4. Now you know that you can see from the output that DF is equal to 4, because there are 5 choices, so 5 minus 1 is 4. All right, so that's fine, nice. Okay, so this is what is the meaning of it. So it is significant. Then what does it mean? It means it shows that there is a significant difference in so I can copy and paste here. So there is a significant difference in observed and expected frequencies in respect of reaction towards COVID-19 of students. Thus, the null hypothesis that there is no significant difference in observed and expected frequencies in respect of this of student is rejected. Okay, and now you know, because the frequency differs significantly, so then you can say here, now in which case you have the higher frequency, it is for strongly agreed. Then you can say that majority of the students, they strongly agreed. Majority of the students were of the view that they strongly agreed towards the reaction towards. So majority of students had a favorable reaction towards the COVID-19. So here it made and this is on the basis of this frequency. Okay, so then you can say it may therefore be said it may therefore be said that majority of students had favorable reaction towards COVID-19. Now, so if you have only one, and you may have 10, if you have the 20 statements, then for each statement you have to calculate the chi-square value. If you have 40 statements, then each statement you have to calculate the chi-square value. Now, many a times, some of the students, they have a scale, they call it a 5-point scale or 7-point scale, or it cannot be 4-point scale, it cannot be 6-point scale, it has to be always odd number. This is important. Okay, so therefore now they ask that how to analyze the data. Now if you want, you can have data on the interval scale, but if you do not want data on the interval scale, you want data on the nominal scale, then fine. Then if you have 40 statements, then for each statement you know the frequencies and you can calculate the chi-square. So this has to be done 40 times. And dear friends, that can be done just in one go. That here you know that you have 40, so enter the 40. Say statement 1, statement 2, statement 3, statement 4, statement 5. So all 40 can come in once, and when it comes to analyze, you go to this and you can shift all 40 on the right hand side. Say I can, like this, I can shift 2. When I can shift 2, I can shift all 40 and I can say okay. Just in 1 second you can do the analysis. So this is the advantage. But understand, to enter the data will be the most tedious task, because this is how you have to enter the data. Okay, and suppose you want to enter 15 and you have entered 14 or 13 or 16, it will make the it will change the chi-square value. So your data entry must be very carefully done. Okay, now let us go. So this is if you have only one variable, and in that you have the categories, and then how do you analyze? Now, if suppose you have two variables, suppose I have the gender on one hand, and I'm taking the reaction towards COVID-19 on another hand. So I have the male and I have the females. Okay, and I have the data. Or if you want to take any other one, okay, I can take another one, no problem. So therefore, I'm now canceling this because I don't want. All right, fine. Suppose let me go to my objective. Suppose I have something like this. I'll say to study the association between gender and reaction and reaction towards ETV program. ETV program of teachers. Okay. And the hypothesis will be something like this. I'm sure you are getting it. So I can write the hypothesis and I only have to change these words. There is no significant. There is no significant association between gender and reaction towards ETV program. Now, if this is, then what do you have? Suppose you have the data something like this. Now, I'm just, let me now insert here. I insert the table and it is this, and I say autofit. All right. Now here I say suppose reaction Now here I say statement. Statement. Now here I say gender. Okay. Now here I say strongly. Suppose I want only 3. Say if I say agree, then I say undecided or say disagree. Okay. Suppose here so this was, the statement was reaction towards ETV program. Okay, this is your male I am taking, and suppose here if I find that these are 20 and if I find this is 6 and if I find this is 8, so that means it will be 35. So male will be, so I'll say 20. So I say agree is 20, undecided is 6, and disagree is 8. Suppose, all right. Now then I go to the next, and next is female. Now if suppose the female here, I take, let's say 10, and let's say I take 6, and let's say I take 10, suppose. Okay, so for in case of male I have 26 and 8, and in case of female I have 10, 6 and 10. Okay, now let us go to the SPSS. I go to SPSS, and let us now suppose if I just delete this. Okay, I have this reaction, so I can go to this. Now I have to once again spell out one more variable. Now there are two variables. So another is gender. And gender has got the two levels. It is one male, two female, okay, these are the two. Now you know that in case of male there are total 34 males are there. So that means if you want to enter the male, so you have to, one has to be 34 times. Okay, 34 times. Now out of 34, you have 20 times 1. So I can just copy and I can paste it also here. Absolutely no problem. So I have to say 20. It is 16. So I say 1, 17, 18, 19, and 20. So out of 34, 20 are A. A means agree, and agree is denoted by 1. So I have to enter like this. Now your undecided is 6, and 6 means 2. So therefore 1, 2, 3, 4, 5, and 6. Okay. And then 8 times you have to say 3. So 1, 2, 3, 4, 5, 6, 7, and 8. Now just see, you can match it. Now this is how you have to enter the data of the male. Now you have the females. And how many females are there? So females are 26. So you have to do it 26 times. So that means you have 34 and 26. That makes 60. Okay. So I have to say 2 till 60. So if you like, you can put like this and then you can copy. So whatever you think is fast, you can do that. Okay, we have almost done, so that's fine. All right. Now please don't go from the bottom to the top. You are likely to make a mistake. So don't do that. Now here, you have to have 10 times A. So A agree means 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So because it is 34 and plus 10 is 44, that's fine. And then you have to say 6 undecided, and undecided means 2. So 2 you have to do 6 times. 1, 2, 3, 4, 5, and 6. Okay. And now 10 you have to do 3. 3 you have to do 10 times. Okay. So you can count. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Fine, 9. Okay. So please, before you analyze your data, you must ensure that you have correctly entered the data. In case of chi-square, by chance, if you have either this side or that side, 1 or 2, it is likely to make drastic change many a times. If there is not much difference, then it will not make. But if there is a slight difference, then one frequency on this side or that side will make. So make sure that whatever the data you have entered it correctly. Okay. Now, where do I go? Say I go to analyze. And if I go to non-parametric, you have seen here in the non-parametric, only you can enter the one variable data. You cannot enter two variable data. Now this is because here we have the gender is 2 and our options are 3. So this is called 2 by 3 contingency table. And you know the contingency, that correlation I told you, it requires the nominal scale data. Okay, so this is also called 2 by 3 contingency. So it can be 10 by 10 contingency, no problem. But you should not have more than 20. That's what is important. Okay, so therefore I cannot analyze with the help of this. And this is the most important one. So please pay attention now. So I cannot go here. So I go to analyze and I go to descriptive statistics. I go to analyze, then go to descriptive statistics, and then I go to the, please see, go to analyze and then go to descriptive statistics and then put a cross in the cross tab. So this is what is crossed. Now you know your row. In the row, you have your gender. And in the column, you have your reaction. Correct? Now you go to the statistics. Now the moment you come here, it is a chi-square. Okay? So therefore you enter the chi-square here and you highlight it and then say go ahead and then say go ahead. Now this is what is your values. You can check your values. There it was 20 agree for male, 6 undecided, and it was 8 disagree. Yes, so it was 34 total. In case of female, it was 10 agree, 6 undecided, and 10. So it's fine. And now this is what is your Pearson chi-square. I told you because why it's not a Pearson correlation. Is called Pearson chi-square because Carl Pearson was the person who invented it. And therefore it is called Pearson chi-square also many times, or you can say chi-square. It doesn't make a difference. Both the same. Now here, this chi-square value is 2.53. Okay, and this is not significant because here it is 28.2% is the error. So the chi-square value is, this is what is the chi-square value is 2.53. Okay, so this is not significant. So let me go to my this one and okay, this is the one. All right. Now here I'm going to add another one, and here I say chi-square value. First chi-square value. Okay, and the chi-square value is 2.53, and this is not significant. Now here I have to table. So if this is my table 3, then I say chi-square value for association, chi-square value for association between gender and reaction towards ETV program of teachers, because here I have taken teachers. Okay, so let me take my objective. This was my objective, and now I go ahead, and now here I take my objective. So let us see. Now here the heading is association between gender and reaction towards ETV program. Of teachers. Okay, now you can say the third objective, whatever the objective, the third objective was to study the association between this. Okay, there were two levels of gender, namely male and female, while agree, undecided, and disagree were the three levels of reaction towards ETV program of teachers. Okay. Thus, the data were analyzed with the help of 2 by 3 contingency. With the help of 2 by 3 contingency, with the help of 2 by 3 contingency, 2 by 3 contingency coefficient. Okay, or you can say that the data were analyzed with the help of the chi-square. That also is all right. Contingency coefficient is also a chi-square you have to use. You can't use any other technique. contingency coefficient, and the results are given in table 3. Okay, so this comes, and therefore here is your table 3. Table 3 chi-square value for association between this. Now you can write from table 3 it can be seen that the chi-square value is 2.53, which is not significant. Okay. It reflects that there is no significant association between gender and reaction towards ETV program of teachers. Okay, thus the null hypothesis that there is no significant association. I'm just copying so thus the null hypothesis that there is no significant association between this and this is not rejected. Okay? Because it is not significant, so it is not rejected. It may therefore be said that gender that it may therefore be said that both male and female teachers were found to have reaction towards same type of reaction towards ATV program, or found to have same type of reaction towards ATV program. So if you copy from here, that both this becomes your finding. Okay, so now let me take one more example so that the value comes out to be significant. And if you have to do that, then how exactly are you going to write? Let us see. Let me take another example. Suppose now I'm taking another example. Let me insert the table and then, okay, and suppose I say here, I say Okay, I'd say subject. Okay. All right. And then let us say here, okay, say the subject I'm saying, say science. Okay. And okay. And let us say I'm saying arts. About these two things I'm saying. Okay. And let us say commerce. Okay. And now let's say I say gender. So I will have a male reaction as well as female reaction in case of science. I will also have the male and female reaction in case of arts, and I will also have the data of this. Okay. Now I just want to say whether the on one side I have the male, I have the female, and on other side I have the subject. Okay. So which subject, let us say, they like the most? Is there a association between the subject which the students select and the gender? So I can have objective like this. My objective may be like this: to study the association between gender and subject, and choice of subject between gender and choice of subject of first year students. Okay, suppose this is my the one, and if I have the data, so I can have the data, or if you like, why can't I say science I say here and arts I say here. I think that's much better. Commerce. Okay. And here, so I can delete these two things. Okay. Okay. And here I say choice of subject. Choice of. Okay. The choice of subject, I'm taking the gender and this one. And if suppose I say, let us say in the science, okay, I don't want to have too large the number, otherwise it will take time. If I say 25, and if I say here 10, and if I say here, say 8, okay. And then let's say in case of female, if I say 28, and let us say arts, or here I can say 8, and the arts, if I can say arts, if I can say, okay, 12. And if I say here, say 10. Okay. Suppose I have this. So I have the male and I have the female, and science I have 25, and arts I have 10, and commerce I have 8. So it is 35, and so it is 43. Okay, it is 35 and 8, 43. And in case of female, 8 science and 12 arts, 20 and 10 this. So it becomes 30. Okay, so therefore that's fine. Now let me go to my data sheet. Now here, now I have to okay, I can, if I want the same gender is already there. So here I can say subjects, or if you want discipline, you can say discipline, or if you want whatever you like. I'm saying subject, and there are say 3. And what are those 3? One is science, and 2 I can say arts, and 3 if I say commerce. Okay. Now I go. Now here, let us see that if I want gender, I have 43. So let us see how many are here. Here it is only, so I have to add more. So let me add more. It is 43. So let me just take and copy paste. Okay. Let us say how many it has come. So I must have 43. So it is 42 and it is 43. Okay. So I have the 43 males and I have 30 females. So that means it should be 73. Okay. So let us see the up to what I have. If I copy this and I copy this here, it is this. I again copy it. So it is 73. Let us say it's 73. It's more than 73. I can just delete. Okay, it's 70. Now, in the subject one, there are 25 people who are male. Okay, and they are in science. So science I have taken as 1. So I have to so if you want this, otherwise if you want little fast, you can copy and you can paste, and this is 25 you have. So this I have 20. So okay, I have done 25. Then I have arts males are 10. So 2 I have 10 times. So it is 25. It should go up to 35. Okay, it has come up to 35. Then I have 8. So let's say 8. 8 is my commerce, and commerce is 3. So 3 should come 8 times. 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so this finishes. Then my female in science, there are 8. So 1 comes 8 times. 1, 2, 3, 4, 5, 6, 7, and 8. So because this was my 44, okay, so 40, this is 8, so it should be up to 51. That's fine, up to 51. You have to be careful in entering the data. Now 12, I want arts makes 2, so 12 times 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay. Now 10 times I want 3 because commerce is 3 and there are 10 people who are in commerce. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So data entry is over. All right. Now I go to analyze. And now where should I go? Yes, you are right. I should go to the descriptive statistics. And in the descriptive statistics, I should go to the cross tab. And when I go to the cross tab, now I want the association between gender. Gender, I have the row wise, and column I have. If you want to change, you can change. That gender, you can have column, and subjects you can have row. No problem at all. It's perfectly correct. Okay, let us see, do you want to change anything? No, you want the chi-square, you don't want correlation. Okay, if you want correlation, then you can find out the contingency coefficient. Okay, all right, I don't want anything, fine, go ahead. Others we can see next time. Override cells, the observed frequency and expected it will take the same one. If you have some specific, then you can do that. I'm not doing anything, so I'll continue. And the format also, it is in the ascending order, fine, no problem. So in anyone, all right. Now this is my chi-square value. Now here the Pearson chi-square is 7.07 and the degree of freedom is 2 and the significance is 0.029. That makes 2.9% error. So that makes my this value of 7.07, it is significant at 0.5 level. Okay, so I can go to my this one and I can add it here. Another, I can insert and I can say chi-square. Chi-square value. Okay, I can add one more and I can say remark. If you don't want this, you need not to do it. Absolutely no problem. Okay, and here the value is 7.07 and here p value is 0.05. But this p should be now small. So now this is the table, and if I say table 4 or 5, whatever it is, and here I say what? Okay, it is the association between okay, so I can say chi-square, or if you want, you can say 2 by 3. you can say 2/3 contingency coefficient for gender and for association between gender and choice, or you can say association between gender and choice. Okay, association, all right. So you can say association between gender and subject, gender and choice of subject. Choice of subjects, okay, of students. Now I can say that from table 5, it can be seen that the chi-square value is 7.07, which is significant at 0.05 level with df equal to 2. Why it is equal to 2? Because gender, you have the 2 levels, so 2 minus 1, and the choices you have 3, so 3 minus 1. 2 minus 1 multiplied by 3 minus 1. So 2 minus 1 is 1 and 3 minus 1 is 2. So 1 multiplied by 2 is 2. So it is column minus 1 multiplied by row minus 1 in case of contingency. And if you don't have that, if you have only one, either column or row, so column minus 1 or row minus 1. But when you have column as well as row, because you have the 2 variables, then it is column minus 1 multiplied by row minus 1. This is how you calculate the degree of freedom. Okay. So, Hannah, is significant at this level will be df thus. It shows that there is a significant association between gender and choice of subjects of students. Okay. Thus, the null hypothesis that there is no significant association. So that there is no significant association between gender and choice of subjects of students is rejected, because F value is significant. So it may therefore be said that gender, that there is a significant association between the choice of the subjects and the gender. Or you can say it may therefore be said that male and female male and female students. Okay, male and female students choose different subjects, or male and female students have their different liking. Okay, male and female students differ significantly in the choice of their subjects, in the choice of the subject. Now, so therefore you can copy from here, and this becomes, so therefore this is, I have taken two examples. In one example, I have taken the value of chi-square which was not significant, another which was significant, and when you had only one, either column or row. But when you had the two variables, and then how exactly this has to be done, I think you have understood it. So far we have done that. If you have the data on the either interval scale or ratio scale, you have wide varieties of the statistical technique. But the choice of the statistical technique depends upon the objective which you have written. Now, next I said, if you have the data on the nominal scale, then how will you analyze the data? So there, the technique I have just now explained is chi-square. Now, suppose if you have data on the ordinal scale, then which technique do we have? You have studied the t-test, but t-test you can use when you have the data on the either interval scale on the ratio scale, number one. Number two, your that normal the dependent variable or your criterion variable should have a normal distribution. Suppose the normal distribution is there, but you do not have data on the interval scale or ratio scale. But if you have data on the ordinal scale, then what do we do? Then which statistical technique is more appropriate? So many a times the students ask that the assumptions of the t-test are not met. Then which other alternative statistical technique that is available and which we can use? So let me tell you that statistical technique, and the name of the statistical technique is Mann-Whitney U test. Okay, so this is the Mann-Whitney U test is the one which you can use if the assumptions of the t-test are not met. Let me tell you quickly the different aspects of it, and then I will take one example and we'll analyze the data and we'll tell you this is how it can be done. All right, fine. Now, I will tell you when to use Mann-Whitney U test, okay, and assumptions of the Mann-Whitney U test. Then how will you word the objectives of the Mann-Whitney U test and the hypothesis and analysis and interpretation and SP. Okay. The Mann-Whitney U test is to be used to compare the difference between two independent groups. The groups are independent, like male and female, like urban and rural, like students belonging to the joint family and the nuclear family, like the students studying in government school or and so on, so say studying science student, etc., etc. Okay. And when the dependent variable or the criterion variable is either ordinal or continuous. If it is continuous, okay, but the conditions are not met of the t-test, so then you can use Mann-Whitney test. Or if your variable is not a continuous one, but it has a data on the ordinal scale, that means you have the ranks. You don't have the score. Either you can have a score. If you have a score, scores can be converted into ranks. But if you have a score and if it can satisfy the assumptions of the t-test, then you will not use Mann-Whitney U-test, then you will use the t-test. But if the conditions of the assumptions of the t-test are not met by your data, then you have another alternative statistical technique. The name is a Mann-Whitney U-test. Okay, and there just say your data are not normally distributed. If your data are normally distributed and you have the data on the interval scale or on the ratio scale, if these two conditions, okay, and one, the homogeneity of variance, if those conditions are satisfied, then you use the t-test. But if those conditions are not satisfied, then you cannot use that, then you have to use Mann-Whitney U-test. So many a times, many of the researchers, they use Mann-Whitney U-test. And it is a non-parametric statistics. Assumption says one variable that consists of two categorical independent groups, like male and female. I have said, example, like male and female, employment, employed and unemployed, transport, bus or car, smoker, yes or no. Okay, trial, whatever the intervention you are giving, intervention given and intervention not given. Even when you are doing an experimental study, and in experimental study, when you have the experimental group and the control group, and the data which you have will be interval or ratio. But if that data do not fulfill the assumptions of the t-test, then you cannot use t-test. Then you have to go for Mann-Whitney U-test. So sometime, even in the experimental study, you can analyze the data with the help of Mann-Whitney U-test. Of course, in survey study, you do use Mann-Whitney U-test when the conditions, when the assumptions of t-test are not met. So something like that. But if you have three groups, then you can't do it. This is important. Like t-test is always for two groups. If it is more than two groups, then you can't use t-test. You go for ANOVA or ANCOVA, whatever it is. So please remember, it has to be used only when you have one variable and there are two groups or two categories or two classes. Otherwise, you can't use it. Then you can have one dependent variable or a criterion variable whose the scale of measurement is either ordinal scale, or if it is interval or ratio, then you are converting it into the ordinal. Because whenever you have the data on the higher scale, the higher scale data can always be converted into the lower scale. And when I say continuous, that makes your data are either on interval scale or ratio scale. So the ratios, if you have data on the ordinal scale, go ahead. But if you have data either on the interval scale or the ratio scale, but your data do not fulfill the assumptions of t-test, then you should not analyze it with the help of a t-test, then you should use Mann-Whitney U-test. Okay? And the continuous variable are, for example, the time is a continuous variable, intelligence is a continuous variable, achievement, marks is a continuous variable, weight is a continuous variable. There are so many variables which are continuous, you know that. Okay. An example of the ordinal scale variable is like Likert. When you have the Likert, which is 5 point or 3 point or 9 point or whatever it is, all these are the one. Okay. Or there may be any other categories which you want to have. That's okay, fine. There must be different participants in each group. So when you have the two groups, they must be independent. So male and female are independent. Those people who are working in the government school and working in the private school, they are independent. So they should be independent. Okay, that's what is more important. And no participant being in more than one group. Yes, independent. That's fine, nice. The scale of measurement must be ordinal. Okay, and there should not be ties. Ties means that if it is a ordinal scale data, on the same rank, there may be 3 people, there may be 4 people. When the same rank is received by more than one person, that is called a tie. So if there are many ties, then this is not very good one. This is very important. So you should not have the ties. If there are ties, then of course it will give certain errors. That's what is more important. Now the objective I'm trying to frame is to compare mean ranks. In the t-test, we were comparing mean scores. Now here, in place of scores, it is ranks. So mean ranks of stress of male and female. Stress is a continuous one, but if it does not fulfill the assumptions of the t-test, then I can use the Mann-Whitney U-test. Another objective can be to compare mean ranks of adaptive behavior of members belonging to the joint family and the nuclear family, to compare mean ranks of achievement in economics of students belonging to joint family and nuclear family. Another can be to compare mean ranks of achievement in economics of male and female students. Like this you can have. And the hypothesis will be there is no significant difference in mean ranks of stress of male and female participants. For second objective, there is no significant difference between mean ranks of adaptive behavior of members belonging to joint family and nuclear family. Then the third hypothesis for the third objective can be there is no significant difference in mean ranks of achievement in economics of students belonging to joint and nuclear family. So please understand here you have to write mean ranks. This is important. Okay. Then for the fourth objective, the hypothesis, there is no significant difference in mean rank. I have forgotten to write in difference in mean ranks of achievement in economics. Okay. Of male and female students. Fine. Now I am taking the data and let me enter the data and let me see how do I analyze with the help of Mann-Whitney U test. And then whatever is the SPSS output, I will take that and put it in the proper order and just interpret and write. Okay, let us now go to my SPSS. Now, before I go to my SPSS, let me go to my worksheet and here let us just say I'm now going to Men Whitney U test. Okay, so this is the statistics which now I'm trying to explain it to you. Okay, so now let me see how do I write the objective. Okay, so I'm writing the objective and I'm writing, let us say one objective is to compare mean rank scores of achievement in economics of male and female students. Okay, and if this is my objective, then my hypothesis, you know, oh God, my hypothesis will be, I can write the hypothesis. Now, you know, the hypothesis, formulation of hypothesis is not now very difficult for you. So I can say there is no significant difference. There is no significant difference in. I think there I forgot to write in, so you can make the changes, no problem. Okay, all right. So if this is my objective and this is, now you know the variables are, one variable is achievement in economics, another variable is gender. So let me go to my SPSS and here say if I write the gender one, okay, because I have already written gender because I want separate one. So if one I say male, okay, and two if I say females, okay, fine, and this I say achievement dot in dot economics. Okay? All right, so I can go here and now I can enter the data. So I am entering the data of the gender. You can enter in any way you like of the gender. You need not to enter all male first or all female first. No, the choice is yours. Absolutely no problem. Okay, if you have, let us enter the score. If I'm taking the score out of 30, then I'm just entering the data. Let me see. Okay. I'm sure you know what am I doing. Okay. Suppose I have entered the data. Okay. Now, where do I go? I go to analyze, and you know, Mann-Whitney U test is non-parametric statistics. So I go to the non-parametric statistics. And now, you know, here you see here, this is binomial, this is one sample, this is two independent samples. Now, just say if you look for Mann-Whitney U test, you will not find. So you must understand that Mann-Whitney U test is when you have two independent variables. So somewhere the names are name of the statistical technique is given, and somewhere, you know, these two independent samples, more than two, and related and unrelated and things of that variety. Okay. So if suppose I go to the independent samples and I go here, now this has come. Now the grouping variable is my gender 1. So I shift it here, and I have to, as you did it earlier, here also you have to do exactly the same. Now, which is your test variable? It is achievement in economics, so you shift it here. Now these are your options. Do you want mean? All right, you can find mean if you want. Now, just see, by default, it is Mann-Whitney U test. So they've already selected it. And if you just say OK, it will go ahead and it gives you the result. Okay. So these are the mean ranks. Okay. Of males, there are 17 males and there are 16 females. So therefore, your male is there, your female is there, your 17 male and 16 female. Okay. And your mean rank in case of male is 10.26, and in the case of female is 25.16. Okay. So I have to have the mean ranks. Okay. And then now I have to have the Mann-Whitney U test, and Mann-Whitney U test is 21.50, and this value is significant at 0.051 level. So it is significant. Okay. So therefore, that is what you should understand in this case. So it is the significant. Okay. Okay. Now I need not to bother about the other things here. Fine. All right. Now I go to my this. Now when I go to my this, let us see what is the heading that I'm going to write here. Now, in case of t-test, you said comparison of means gender-wise. So here we say gender-wise, comparison of, now there we say mean scores, here we say mean ranks. Mean ranks of, it is achievement in economics of students. Okay, so this is the heading which you have. Now you say the variable, the objective was, because this is the, I can say the first objective. Okay. Or if you want sixth, seventh, whatever it is. The first objective was to compare. The first objective was to compare mean rank scores so the comparison of mean rank scores to compare mean rank scores of achievement in economics of male and female students. The data were analyzed. With the help of Mann-Whitney U test. With the help of Mann-Whitney U test, and the results are given in table 5. All right, are given in table 5. Okay, are given in table 5. All right, so I'll say table 5, and I say here gender wise. Mean rank scores of achievement in economics of students. Achievement in economics of students. Okay. Now here I can insert my table. So I can go insert and insert. Okay, I'll say insert. I say auto fit. Okay. Now here I'm saying gender. Okay. Then I'm saying N, or I can say mean rank. Okay. And then I say N, and then I say Mann-Whitney U value. So I'll say Mann-Whitney U. Okay, so this is Mann-Whitney U value. Okay, and here I can say remark. Now, let us say, now here I have the males, then females. Okay, and the rank for males is 10.26. The female is 24.16, and the 17 are male and 16 are female. If you want capital N, no problem, you can say capital N. And this value is 21.50, and this is significant at 0.01 level. Okay, so I make it all right. Now I say from table 5, it can be seen that Mann-Whitney that the Mann-Whitney U value is 21.50, which is significant at 0.01 level. It indicates that there is a significant difference in mean rank scores of achievement in mathematics of male and female students. Of male and female students. Okay. The way we have already written for the t-test, and now I can say, I can copy this, thus the null hypothesis that, now I am copying paste, thus the null hypothesis that there is no significant difference in mean rank scores. So I have not written this. Okay, mean rank scores of achievement in male and female students is rejected. Okay, because it is significant. Further, the mean rank score of achievement in economics of female students is 24.16, which is significantly higher than those of male students whose mean rank score of achievement in mathematics is 10.26. It may therefore be said that female students had significantly higher achievement in economics as compared to male students. And if you just copy paste this much, then that takes care of your finding. So thank you very much. Now over to the organizers for questions. I have tried my level best to explain whatever I wanted to explain in the given time. Thank you very much. Go ahead with the question. Neetaji. Hello.
Yes, sir.
Yes, please. Go ahead with the question. If any
Sir,
question,
today, as it is last day, there are more questions actually. So we'll go one
very
by one. So the
yes.
first question is there any other statistical techniques under non-parametric statistics except chi-square test?
Yes, just now I have said Man Whitney is there, Friedman analysis of two vents. There are many. Those who are interested, I am giving you the reference. There is a non-parametric statistical. It is, at least I found it very, very easy and interesting. So there are many, many. So two I have demonstrated, one chi-square and another is a Man-Whitney U test. Next question.
Okay. If we want to check the reaction of people towards COVID-19, what should be the wording of questions under reaction questionnaire or scale? Could you please explain, sir?
No, I am sorry because I am not here to help you like this. I am only here to answer the question related to the topic. I am not going to word you the question. Okay, fine. It's up to you. And it is not a reaction questionnaire. It is a reaction scale. Please
Okay.
understand. So this is not correct. So I will not answer this question because it does not relate to the topic. And the topic is chi-square and Man-Whitney U test. Next question.
Okay, sir. Do we have table value for chi-square?
Yes, we have the table value. It is given in many statistical books. Like in Garrett, it is given, and many other it is given. Next question.
Reaction towards NEP 2020 of College Teachers of Tamil Nadu. In this statement, what kind of scale is good? That means like a 3-point scale, 5-point scale, or 7-point scale.
Because you are taking the mature people, so 5-point scale is much better than the 3-point. One should not take 3-point. Although this question is related to the tool which I have already covered, but I can help you out. It has to be 5-point, not if it's a small children, then you 3-point is all right. But if it is mature people, 5-point is okay or 7-point is still better. But the difference becomes very, very critical. Next question.
Okay. Can we use chi-square test in case if we have 300 or 400 samples?
Yes, if you have 300 and 400, you can use chi-square, but only the problem is you have to have patience in entering the data. But chi-square test you can use. Next question.
Chi-square test and standardization of the questionnaire are same, sir. How to eliminate the question from the questionnaire?
No, this is not related to the today's topic, but I'll tell you, when you standardize it, chi-square is never used. We don't use standardization chi-square. No, chi-square is never used to eliminate the questions. This question is related to the tool development and standardization, which is not the topic for today's. So I will not answer this. Next question. I have answered indirectly,
Yes, sir.
stating that chi-square test is never used when you are standardizing, and the questionnaire can never be standardized. The questionnaire can never be standardized. You can only standardize either the test or scale or inventory. But questionnaire can never, never, never be standardized. It's a wrong information if the teachers are giving. That means they do not understand the tools. Next question.
Okay. How interval scale converted into nominal scale? Please explain with an example.
I have explained. I have taken the data achievement in a economics. Okay, this you can very well convert into, you say, higher mean, high achievement, low. Then you can find out how many people are having high achievement, how many people you can convert it like that. It's not difficult. Next question. See, when you have a exam, and in the exam, when you have a list, you can find out how many students failed and how many students passed. So your achievement in examination, it is on the interval scale, and you can find out how many students failed and how many passed by counting. This way you can do it, no problem. Next question.
Okay. How the chi-square value 9.89 is significant at 0.05 confidence level?
Now you compare it with the standard table, and standard table indicates it is significant. Then how can I say, how can chi-square? I have no answer to this question, because whenever we want to find out whether our calculated value is significant or not, we have to compare the calculated value with the standard value. Now, when you want to find out the weight of a person, whether weight of the person is normal or is not normal, or average or not average, you have to compare it with the standard value. So we compare the calculated value of the chi-square with the standard value, which is given at 0.05. And then you compare, and you know, if your calculated value is either equal to the table value given under 0.05 or more than the table value given under 0.05, but less than the table value given under 0.01, then the value is significant at 0.05. I have already given you the 3 rules, and those rules, if you were present, the person who is asking the question, if he was present, he
Yes.
should know it. Next question.
Yes. Yes, sir. Can we take caste and gender as variables of chi-square test?
Yes, you can take. Next question. You can take, no problem.
Yeah. Can we have any number value for chi-square or have any limit like minimum or maximum value?
No, no, there is no limit, only the total number, your sample size is only limited, otherwise there is no limit. Next question.
Yes, sir. That was the last question. And few questions were repeated actually, so we couldn't take those questions as it was repeated. And we
No.
are at the end of the session. And I have a word for you, sir, especially. Better than 1,000 days of diligent study, it is enough to spend one day with a great teacher like you. Thank you so much for all these days you were with us, sharing your knowledge and experience. It was very fruitful session. I consider it's a great privilege to propose a vote of thanks to all the dignitaries who have witnessed it as a memorable and successful event. Today, my words are not enough to express the gratitude. On behalf of Department of Computer Applications, SSMRV College, I would like to thank our respected resource person, Dr. D.N. Sansanwal sir, for his endless effort towards this program to make it more successful with his knowledge and practical skills. Every day was a new beginning with new learning under your guidance, sir. I extend my gratitude to Dr. Pramod Kumar Gupta, sir, founder, Indian Teacher Education Community, who coordinated and graced us with his support in organizing this wonderful 15-day program. I thank our beloved HOD, Mrs. Shanti Krishna, for initiating this program to set a perfect platform for all research scholars, students, and faculties from various colleges to benefit from the program. I would like to thank our beloved principal for all words of wisdom that radiated a source of energy within us. We will ever remain grateful to you and we thank you for being with us today, sir. I acknowledge Mr. Shubham, technician, ITEC, for his support in organizing flawless event. Heartfelt thanks goes out to all our faculties, participants who are actively participated in all 15 days. I feel proud and thank you for making us feel happy with your participation to this event. Thank you, one and all. Thank you, sir.
Okay, thank you, Nita. Special thanks to you from our side. Thank you. So nice of you.
Thank you, sir.
Okay. All right. I'm leaving.
Hello, myself Dr. Pramod Kumar Gupta. Many thanks to you all participants, all organizing team, Srimati Krishna Madam, Principal Sir, Resource Person Dr. D.N. Sansanwal, Technician Mr. Shubham. Many thanks to you all. It was a challenge for us, 15 days program, but we have completed it, and we are making some another programs. We will inform you with your certificate after 1 week. तब तक के लिए आप सभी को नमस्ते, सत श्री अकाल, सलाम.